I am here to talk about Bank Python, um, and there will be a little bit of audience participation. So beware the front rows. You may get wet. Um, so, what is Bank Python? It is the alternate universe of Python used by big investment banks, basically. And they have effectively forked the entire ecosystem, including the interpreter, the standard library, and even bits of the stuff on PyPy. So the whole hog. So for example, what have I got next? Hang on. So to, there's a little bit of lag on there. For example, the system is in use at Goldman Sachs, to some extent at Morgan Stanley, and many, many others. There's about three, I would say, big instances, a number of smaller ones, and then there's a kind of white label version of it that places can buy and run, rent almost as a cloud service, I suppose. So has anyone here used this before? Have anyone worked within these companies before that used this? Okay, good. Maybe that means it'll be exciting. So who am I? I'm Cal Paterson. I am a contract software engineer of many years, contract for about 10 years. I've worked for longer than that. I'm an organizer of this meetup, and as I've said, we need speakers for next month, and indeed we need venues. So if you or your employer or anywhere has a place for us to host this, please make yourselves known. I'm also new to Finland. I moved about 4 months ago. So far, so good. It's a little bit unusual not to have my shoes on. I feel like I'm in Japan, actually, at the moment. And if it happens, I'm also looking, I might as well say, I'm looking for a new contract right now. I've moved to a new country. So if you have any leads on that, please tell me. I've worked with Bank Python. I've worked with it in more than one place, and in kind of more than one setting. So I hope I can shed some light. And I have a blog, as probably a lot of people do. And I was casting around for a topic to write about on my blog. And I thought to myself, well, I'll try and write about this crazy stuff, which I thought was interesting, would be relevant. So I did. And friends of mine who I've worked with, who I showed it to, thought it was actually much too boring and that no one would be interested in stuff inside these kind of companies. But there was quite a lot of response. It was number one on Hacker News. It was very popular on Reddit. Lots of comments. I received emails from people. Indeed, some of them still don't believe that it's true. They think I'm making it all up. You have to decide for yourself. It was even, as I learned, if you have a popular blog post, people do unsolicited translations into other languages. This one is Russian. There's other ones which are translated into Japan and Japanese. I couldn't find that on the internet. Maybe it's taken down. I think this is some kind of SEO game. Anyway, there's also Chinese as well, which was good fun. And I read people's comments in other languages too. So what I'll say, I'll talk about it as Minerva, which will be my name for these group of related big systems. So I've got a 3-course menu for you. And I'll talk about, first of all, the main database. I'll talk about the repricing engine, which is Dagger. And I will talk about the monorepo that they have. So I'll talk in a sort of slightly idealized way. So I hope I'm not going to tell any fibs. I'll try to be fairly honest about what it's like. And it can be very bright at times and also very dark as well. And I'll sort of observe the various non-disclosure agreements which I've signed, which is why I mentioned Goldman Sachs. I've never worked there, so I've never signed a non-disclosure agreement with them. So I'm happy to talk at length about their system. Other systems I can't talk about because I've agreed not to. So, starting with Barbara. Barbara is basically a bank-wide database of Python objects. And it is global. You use the same database in New York that you do in London. Same you use in Malaysia. If people are using this in Finland, there's no evidence of that tonight, but perhaps they are, then you'd use the same database here as well. It is hierarchical in a way, a bit like Amazon S3. So the kind of global namespace, you can chuck your stuff in. There are no transactions. So you write your objects, your object gets written or it doesn't. You have that at least. But you don't have any you can't write multiple objects, just write one at a time. There are, of course, it's still banking. There are permissions. There's a big permission system. You can't just write anything you want, though, broadly speaking, you can read whatever you want. So it's open in that sense. I'm not going to talk about the permission system for reasons of time. Also, it's much more boring and indeed far darker than I'm willing to talk about in public. So this is some sample code. In this Python program, there's my laser pointer. My laser pointer does not work on the screen. You start off by importing Barber. It's a top-level module. Then you create an instance of the database with barber.open. And you can pull out whatever you want. So in this case, we're pulling out some bond. In the UK government bonds are called gilts for reasons too boring to go into. You can pull out your gilt, and then you can just about see at the bottom there, you can value it. So you can find out what the gilt's worth today based on current market prices. And that's fairly straightforward, and you hope it would be, because this happens quite a lot. It's a bank. They have to value stuff all the time. That's part of the job. So that's easy. How does it work? Well, effectively, it's pickle and zip. That's how it works. Except, well, it's not quite pickle. I'm telling you some fibs here. It's not quite pickle, and it's not quite zip. But if you think about pickle and zip, you have a kind of idea in your mind of how you might implement it yourself. And that's how it works as well. It is incredibly, incredibly reliable. In all the time that I was in these various places, I never saw any major outages. I very rarely saw minor ones. Cases where some values were late, but you were told it wasn't a big problem, and it worked well enough to run a big bank big bank on. There are also secondary databases. Probably won't be surprised to learn that means SQL. You'll know SQL, perhaps structured query language. Most databases run on SQL. Also used is something called KDB. KDB is, if you're not familiar with KDB, it's sort of a kind of specialized financial database for numerics, and it comes with a kind of programming language in the deal, a bit like SQL, if you like. It kind of descended from the APL family of languages, and it was particularly popular at Morgan Stanley. Well, it hasn't worked, so I can mention it. Second thing, so Dagger. Indeed, this is possibly the biggest bit. So Dagger is a kind of rolling repricing system. One of the things that you have to do in a bank, indeed in any financial place, is just constantly know the value of the stuff that you've got. Stuff that other people have got, stuff that other people owe you. You have to value this all the time. You're constantly valuing stuff. You're valuing financial instruments, which is a big word invented by regulators. But a financial instrument is fundamentally just a contract that involves money. So someone has to pay someone with something. Perhaps they're not paying you with money, but there's some kind of valuation to it. So things like shares, bonds, obvious things. Less obvious are derivatives, which are basically things based on other things. That's why they're called derivatives, derivative. Futures, options, swaps, those sorts of things. So for example of an instrument would be Kone. Is that, am I saying that correctly? Great. So they were a lift and escalator manufacturer. I've tried to use a local example here. They have shares on the stock exchange, and that's an instrument. So easy as that. The universe of financial instruments effectively forms a directed acyclic graph, or DAG. For example, so at the top here you can see this is sort of a directed acyclic graph. At the top you have equities, which I have not really translate these words. Usually outside banks, you call equities shares. You have convertible bonds, which are just like bonds, except they also they can be converted into stocks. So if your bond is doing badly, you might convert it into a stock. So they're said to participate in the share price. So bonds related, they're dependent, they're derivative of shares. And credit default swaps, which are now notorious. I've worked with them quite a lot. They are effectively bond insurance. And they're, of course, the value of buying CDS is dependent on the value of the bond. And then you can, of course, have baskets of CDS where people batch CDSs up, you sell them, 25 different CDSs. Perhaps you want to buy CDSs on all of the Italian bonds or all of the bonds of whatever. You can do that. Someone will sell you that. Here's some example source code. So this is a credit default swap. As I say at the top, in the doc string, I'm a good boy. I always write doc strings. Credit default swap pays some money. It pays some money to you when a bond goes into default, i.e. when the bondholder stops paying it back. And you have a done during it method. You have a call to superclass where you pass in the underliers, very obvious. And then at the bottom, you have the value method, which you can call if you want to know the value of this CDS, credit default swap. And it returns some number, a float, right? That's the value of credit default swap. And that's how Dagger works. So if you want to know the value of an instrument, you can call value. Easy enough. Next thing, building block on that, positions. So a position, which you might enter into, position is a specific instrument and a quantity of it. So if I have 200 Coney shares, that's my position, at least as far as Coney is concerned. Again, this is real code that well, not real code. This is like the real code, which you would see in these companies, in these banks. So you have a constructor done to a init. It says, again, good boy, I write the doc strings. Position is an instrument and how many. So you have a float for the quantity. Quantity has to be a float because you can have fractional, some instruments are fractional. So to cover my bases there, I've got a float. Floats are great, love floats. Finance loves floats. And you have another method done there, much like the other one, value, where you can get out the value of the position, which is just going to be the value of the instrument times by however many. Easy enough, right? Next and final step, a book. Book is one of those words that gets used a lot in finance. So a book is all of the things you have. It's just the set of positions, right? And sure I've got this. Yeah. So if you have 200 Coney shares and 100 Nokia bonds, then that is your book. If I'm the Cal Paterson trading hedge fund, Cal Paterson hedge fund, it'd be Cal Paterson Limited Partners. That's what you call it. That sounds professional. You have 200 Coney shares, 100 Nokia bonds. That'd be your book. And you want to value your book all the time because you want to know how much money you had. That's why older day banks are called counting houses because you have to count stuff all the time. Okay, so I won't show the implementation for book. You can imagine what it might be. A book is just a sum of the values of the positions. So hopefully simple. The books are kept in Barbara. You can pull them out. You can find out the Euro CDS Desk's book, pull it out. Indeed, when you work at a bank, you can do this for any desk. And you can print the value. And CDS desks, at least, have quite frightening values. Quite frightening indeed. So it can be quite scary. If you want to value the UK business, say Morgan Stanley's UK business, you can pull out that book, right? Books can be built off top of books, and you can value that. And that gives you an even more terrifying number. Hopefully positive, this one, hopefully positive. Positive is generally good. All else considered equal, positive is good. You can value the whole bank. So you can pull out the book for the whole bank. Books are hierarchical. And if you value the whole bank, The number will be enormous. It won't make any sense, but at least you can do it. And in theory, the chief financial officer would do this. In practice, they use something different, but they could do it. And so, as perhaps many of you will have found out, data has dependencies on other data. And instruments and books and positions are dynamically and automatically regenerated all the time in Dagger. This is part of actually the kind of national myth, if you like, of Minerva. The myth is that back in the day, in 2008, Goldman already had this, and they were able to price all of their stuff all the time. They could find out their exposure to stuff, to the bad old stuff, the toxic loans, blah, blah, blah. And they could dump them quicker than anyone else, that was the name. If you were around 2008, I was not. You wanted to dump this stuff quicker than anyone else could value it. So if you have better at valuing, you tend to do better. And that's true of banks in general. If you're better at valuing stuff, you do better. So does this start to resemble something else? Do you recognize perhaps something else this may be emulating? I will pause for dramatic effect and I will go on. It resembles Excel, Microsoft Excel. So Dagger is an attempt, actually fairly successful, at least some banks, to replace Microsoft Excel. Microsoft Excel, the sheets also form a directed acyclic graph. If you think of the cells in a sheet, each cell depends on one or more other cells. Cells aren't allowed to loop around. You'll find that doesn't work. Excel's great. People build real businesses on Excel. It's even possible to build real desks, maybe even real hedge funds. But life becomes hard if you're using Excel. It's hard to look up external data, for example. You can't VLOOK into other sheets very easily. It is possible. It's hard to version control Microsoft Excel, and it's hard to write tests. So I've never seen anyone write unit tests for Excel. I've heard it's true, never seen it. And it's really, really hard. This is the kind of killing blow. It's really hard to write complicated maths in Excel, and people get it wrong all the time. I've seen academic studies withdrawn because of Excel mistakes. So what appeared at first to be statistically significant turned out not to be, and because of a rounding error or the wrong operator or whatever. Sorry? Or date, indeed. Oh yeah, don't even get me started. Oh, God's truth. God's truth. No, I won't even go into it. There was someone recently who changed their date format so it wouldn't get part of a number in Excel. A scientific community changed their date format. Is it genomes, maybe biology somewhere? Yeah. Okay, so you can perhaps see the value. If everyone in your organization is using Excel, then you can't see what they're doing. You can't price their stuff. You have to hope the numbers they send you by email every day are going to be right. Using Dagger means that you can observe everyone else. That's nice. The third thing, final item on the menu, is the monorepo. Minerva uses a monorepo. All the source code is stored inside the database. Yes, it's true. There are around, I would say that some of these banks have 5 to 10, maybe 15,000 people working in Minerva per installation. So there'll be multiple banks. And, they haven't fallen over. So I suggest that there's something to this. So in Python, when you import a module, fic.europe.uk.cds. blah, 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 that just reads the file out of Barbara, right? So Barbara better work. So when I said it's reliable, it better be, because you can't do much. You can't read your source files. You really are, you're up the creek. And of course, corollary to that, if you store your source file somewhere funny that's not in the file, then you have to have a way to edit them. And indeed, Minerva has a special in-house IDE, which has been written. You see now why they forked the Python interpreter, because I think it's possible now to have import, to kind of set up your import statement in the interpreter using import lib to have it read from a database. It wasn't in 2007, 8, 9, whatever. And indeed, I think that's why some of the banks got stuck on Python 2.6 because they wrote this hack into their interpreter. Python changed the way that import machinery works, I think in 2.7 at some point, and they had to change it to match. So we were stuck on 2.6 for a long time. People complain about being stuck on 2.7, stuck on 2.6. Like there's no dictionary comprehensions in 2.6. I still never write dictionary comprehensions because I'm just inured. I don't think they don't exist. Um, so, yeah. So that's how that works. In Minerva, there's not much RPC. People talk tonight about their systems for calling APIs and whatever. There's APIs in Minerva. When you call someone else's function, when you want to call, if you're in equities and you want to call a function from debt, you just call their function. When I say there's no magic, there's really no magic. You are calling their function. That's it. It better work, right? When you write your code, you have to remember it's going to run in someone else's interpreter inside their code. I'll come on to this. This has some implications. So if you break someone's interface, if you've broken an evaluation function like that, it's on you to go through and fix the cause. That's your fault. You have to fix that. Indeed, that's how Python 3 was done. So there was a Python 3 team, and they would visit you, and they would change your code to make it work on Python 3. And you would sit there and you would shout at them because they were introducing breaking changes or they were whatever, right? And you hated them. And they were like, you did not care a fig because the people who pay you, they don't care about Python 3. Anyway, so that's how Python 3 was done. Indeed, how every major change is done. Someone breaks the API, they have to go through, they have to fix it. And they have a concept here. I've never heard it outside. Ghost tests. So what these are, they are the tests of others, right, which run against your code. And if their tests fail because of your changes, your change gets backed out, right? So if you change something and you break someone else's code, it's not just cultural. There is process. They will find out your change will be reverted. If your breaking change gets through and doesn't break their ghost tests, then they won't find out immediately. They'll find out later and you'll get a phone call about it and they will not be very happy. This does exist in another community outside of Python. I believe, I don't know for sure, that the Perl community has something similar on CPAN, where they run tests of other modules against your module. I haven't really looked into it in too much detail. I said I'd talk about imports. I will talk about imports now. Imports matter a great deal. When everyone is importing your code, import time becomes a big stressor. Slow imports make everyone grouchy and unhappy. They don't want to take the time to import your code. I wouldn't want to take the time to import my code. And import time is consequently greatly measured and reported upon. You'll see immediately in your IDE if your module imports slowly. Tangles are a problem. When I say tangles, I'll just define what an import tangle is. So occasionally, what can happen? I say occasionally. It happens eventually. Eventually, what will happen is that there will be a certain order of your modules which they have to be imported in. Otherwise, you start to get circular import errors. Can you raise your hand if you've seen this before? This is something that everyone eventually runs into. And indeed, every company runs into. I read a fascinating series of posts, I think while I was working in a bank, by Dropbox about how they'd sorted out their tangle problem. They had a terrible, terrible tangle problem in their desktop app. Of course, the wider you're shipping your code, the more you care about your tangle problem. Anyway, so for what it's worth, other languages do not necessarily have this problem. It's not unique to Python, but others don't have it. So for what it's worth, Java does not really have this problem. It does in some respects. Languages which really do not have this problem, standard ML and Haskell do not have this problem. In standard ML, I think, in Haskell I know for sure, Haskell is very big in the UK. In Haskell, you can have what's called mutually recursive modules. And if module A imports from module B and module B imports from module A, that's fine. That'll work, that'll compile. More difficult if you're an interpreted language, but Haskell is an interpreted language. It's compiled, but it's also interpreted. And I think actually the issue with imports is one of the kind of, dare I say, at a Python meet, it's one of the mistakes in Python. One of the mistakes, way too late to fix. One of the mistakes is that you can't do imports in the way that you want. Consequently, what happens? It is considered polite. If you're importing a big library, think of pandas, of, I guess, Django, SQL Alchemy, something big, often with a native code component. So pandas is ideal. It's considered polite. If you're not really using it in your file and you just use it in one place, then you put it inside the function or functions where you're using it there. Where you import some big C++ lib, it goes inside the function definition. That is considered polite because it means that other people don't have to wait for some big CPP lib to import if they're not using it. Next. Staging environments. I'll talk about staging environments now. There are no staging environments. There are two modes that code can be in. It can be in production or it can not be in production. It's very simple in a way. Either it's there or it's not. You know, I've had people say to me, they said it's very simple. Either your code's in prod or it's not. And there's something to that. There are effectively three rough stages. The code that's on your machine in development, actually it's not on your machine, it's in the database, but pretend it's on your machine. Then there's code that's checked in. I mentioned in passing here, they have their own version control system. So your code that's checked in, that's not in prod. You check it in, not in prod. You're going to get it reviewed first, right? And the third stage, of course, that's in prod. Hope it works. Servers will only run prod code. In fact, if you're shipping your app as a desktop, well, shipping, I'll come on to this, there's no shipping. If your program runs as a desktop UI, right, you have to be in prod as well, just the same. So if some trader wants to open up your thing and he's running your program on his Windows machine, your code has to be in prod, no exceptions, has to get reviewed. Why is there no staging environment? Why? The biggest reason is that it would slow down, well, maybe the second biggest reason, it would greatly slow down the release process. And you must release fast. Not only to correct issues with your previously quickly released software, but indeed also to respond to changing market conditions, right? The last thing anyone who is trading something wants to hear from you is that you have to wait for a build pipeline. They don't know what a build pipeline is, and they're not interested in learning, certainly not interested in learning. What I would say on this point at least is that one of the rules of running a bank or desk, perhaps any business, is that the survival criteria is that you just have to make more money than you lose. And so, like with humans, some people think that humans are built ideally with 2 legs and 2 arms, we're perfectly designed for our environment. But perhaps the real reason is that it works okay and doesn't interfere with reproduction too much. And that's the fitness function for us. And so for banks, it's the same. The second reason, this is the biggest reason, getting the data straight is really hard, really, really hard. Most code is data-based. Banks are enormous, markets are enormous. To meaningfully QA your code, you'd have to set up all sorts of things, which makes it very hard. So that actually writing manual QA scenarios much more difficult than it looks, right? Automated tests with canned data are the way. There are lots of requirements about automated tests. They're certainly going to check your coverage. It's checked automatically. You can't even check in, I believe, if your coverage is less than 80%, right? So if you lower the coverage in a file, you can't check in without sign-off from a director. So how does this review process work? It's done by the vouch process. So familiar from GitHub, you find a code owner, they approve your change, and then it's in prod because there's no deployment step because your code was already in the database, right? So there's no such thing as shipping. That's right, there's no shipping. It's already there. Even if it's not in prod, it's there. So what else do I have to talk about? I'll briefly talk about the other things, which I don't have time to cover. So other stuff they have, which I think is rather exciting. They have a single bank-wide job runner. It's a bit like a kind of mega Jenkins, right? It's enormous. Everyone runs on the same bank job runner. They have a proprietary table library, similar to pandas. Why do they have this? Why don't they use pandas? There were lots of problems with pandas in 2008. I think one of it is it didn't exist. But there are other problems too. So pandas has always been, was always quite slow. It still, I think, having used it recently, it still uses too much memory. That was exciting. I thought the disco was at the start. Someone told me this was a nightclub. I thought we were about to begin. Anyway, still quite memory hungry, which proves to be a problem. A big problem is that pandas doesn't work with data that's larger than your memory. That's still true now. It's about one of the biggest downsides of pandas for anyone. So when your data gets bigger, you have to suddenly change technology. That's no fun. I don't like finding out about that. And the other one is path dependency. Once you've written something, you're going to keep using it. They also have a proprietary time series data structure, which usually is called the curve or curve type. Sometimes it's called not type. Time series are a bit funny. One thing to think about time series data is that each value usually changes only a little from the previous value. So if you think about a history of the price of something, the price of Kone, every day it only moves a bit, right? It moves maybe in eighths worth, right? Or a float eighths worth. And so there are optimizations you can do to time series data that they care about. This is starting to come into other places. Snowflake has something similar now. They have a similar sort of trick, I believe. There was at the time something called MonetDB, which Snowflake is based on, or at least is descended from, which existed at the time, but not in the way they want. And they probably wouldn't have adopted something weird and academic anyway. Barber has time travel, largely for Dagger. So you can look at the model's output from yesterday. There's time travel. The permission system, which I didn't talk about, won't. It's based on Prolog. The source files checked into Barbara. The built binaries are too. Obviously, once you got everything in a database, it's just more database row, isn't it, really? They have these replay-oriented financial message buses. So in finance, you're particularly interested in replaying the past. If you change your strategy, you want to see what would have happened in the past. And so you want to use your message bus to do this. They also have Microsoft Outlook 2010. That one's not so great, actually. Did not enjoy. Where to find out more? On my website, I have written in more detail about this. I cover some of the same topics. There's not 100% overlap. There's about 40% overlap. You can find out more there. And I will now open the floor for questions. Things worth mentioning. So I stopped working in Minerva 2021. That'll affect my memory. A lot of my mates still have their hand in working on it. So I still hear about stuff. And I'll try my best to answer if I can.
'Too many questions because this is like first impressions were like Jesus fucking Christ all the time. But yes,
it feels normal when you're inside the cage.
Yeah, I know. I've been in similar situations. So one thing is this: that when you're developing your code, and there's resource constraints, and then the thing goes to production. So I guess that the developers' machines, they can always run at least as fast as where this is going to be deployed in, or something like that, because you're going to break the production immediately when somebody approves it.
Yes, production is uniformly bigger than your desktop machine. Yes, you can get bigger machines, and often if your program is running slowly, you'll get a bigger machine under your desk. That's no problem. Yeah.
Okay, so how about the ghost tests in that case? So if you're developing something and then you break somebody's ghost test because the performance doesn't work or something.
ghost tests, you'll receive email about it, and your code won't go to pod. You can see the ghost test running in there. They run in there. I mentioned the big job runner thing. They run in there. You can go and find them. Usually they're like so boring. You don't think about them much. When you get email or something, then you care because you can't get your stuff into pod. Then you're really interested in what happened with the ghost tests. I'm being flippant. You care. You do care quite a lot about correctness, and you do try very, very hard to get the right numbers out of your program. But yes, that's how that works. So ghost tests, they're running in the background all the time. You can skip them. You need some level sign off to skip it. The way that banks work internally, by the way, you can do whatever you want as long as you have sign off from an appropriately senior person. The verb that tends to get used is to risk accept. I risk accepted. You risk accepted. He risk accepted. And you're said to have risk accepted the change. Accept with an A. You risk accept a dangerous change. Or rather your director, actually. Ideally someone else. It's best if it's someone else will risk accept your dangerous change. Which, as I said, you only have to make more money than you lose. It's an important rule. Don't forget it. No business is different.
So you mentioned that the programming model or the data relationship model resembles Excel. So now that Excel also has Python, have you considered, or would it be possible to replace the front end or the desktop software with essentially Excel that's running Python to retrieve all the Minerva classes?
Imagine you are the director of a set of desks that trade in credit default swaps or something equally dangerous. Would you risk accept that change? I wouldn't. I wouldn't let them. If it comes up anywhere, someone asks to do something you don't think it's a good idea, you wouldn't. I wouldn't. I bet you wouldn't. Would you go back to Excel? I mean, God help me, I wouldn't.
A thing about this Python 3 migration. So it apparently it happened.
That's right.
Yeah. So
Python 2.7 did not really happen.
Yeah, I would imagine that at that point it was moot point. Yeah, but congrats on that.
Thanks. I didn't do anything. This guy, he did it all. They had a central team somewhere in, I don't know, somewhere in America. Incidentally, I'll say this because I am being recorded, but I haven't mentioned places I've worked. One of the interesting facts about the intercontinental difference in a bank is that in Europe, at least before, there weren't any big startups you could go work for. You couldn't go and make £250,000 a year working for Google or something in London, right? You couldn't do it. You couldn't do any of that stuff. You couldn't go work for Facebook. They didn't exist. So you had to work in finance because the rents are high in London. They're very high. The childcare cost is high, and you had to go work for a bank. In America, you can go to California and work for these companies. So if you're good, you'd probably try and do that, wouldn't you? Makes sense. So who's left working in the New York office, right? People who work in the New York office, they tend not to be as great. So if you find people who are in other countries where there's no alternative, where the best place to work is a bank, they tend to be pretty good. Places where there's lots of alternatives, they're less good. Right? So some of the best people who've moved from outside the US to the US, fact of the visas in the US, once you move to the US on a work visa, you can't change employer. So you had to be good to move there, then you can't go anywhere. Those guys tend to be the best guys in the bank. Okay, I assume there's no more questions, so obviously everyone thinks it's very straightforward and quite self-evident, a good idea. I'm available later on to chat about it as well.
Great, thank you, Cal.